Dear friends, good evening and welcome to the program. Now, yesterday I told you some basics and I hope you might have understood. If there is any question you want to ask, then you can ask me the question and then I will proceed further. Any question, any participant like to ask, you can type it in your chat box or question answer box. I will see and I will try to reply your question. If there is no question, then I proceed further. Now, in this particular webinar, we are only concentrating on the non-parametric statistics. We are not be touching the parametric statistics, which are very strong statistics. So we are touching the non-parametric statistics. And one of the non-parametric statistics that I am going to take today is the Kendall's law. Kendall's law B. Now, this is the name of the statistical technique, and Sunil, the power of a statistics means if the hypothesis should be rejected and your statistical technique helps you to reject the null hypothesis, then it is powerful. If your null hypothesis should not be rejected, and if your statistical technique helps you not to reject the null hypothesis, then also it is powerful. It means if it is true, then it is true. So that is what is the power. And when it is not powerful, that means your null hypothesis should not be rejected, but your statistical technique may say that you reject the null hypothesis. So this is not correct. So it is because the statistical technique is weak. And this can happen when you have a weak statistical technique. So that is the meaning of a power of a test. So the non-parametric statistical techniques are less powerful. They are not at all powerful. So I hope you have understood now. Now, Kendall's law is a non-parametric statistics, and the assumptions are now let me first tell you that do you know the Pearson product movement correlation? Pearson product movement correlation. The assumptions are, one is that there should be two continuous variables. And each variable should have normal distribution. Now, if suppose there are two variables, but the distribution is not normal, then you cannot analyze your data with the help of a Pearson product movement correlation. So what is the alternative? The alternative is the Kendall's law. You can use the Kendall's law to study the correlation between two variables when each variable distribution is not normal. Number one. Number two, the two variables may not have data on interval scale or ratio scale. They may have data on the ordinal scale. So if the assumptions of the Pearson product movement correlations are not met, then you can use the Kendall's law. So one is that there should be two variables, each having data at least on the ordinal scale. Another is the distribution of each variable is not normal. So if these are the conditions, then you can use Kendall's law. But if you have the two variables and if the distribution is normal and the scale of measurement is interval or ratio, then you cannot use the law, Kendall's law, then you should use product movement correlation. Now here, if the data are on interval or ratio scale, but the distribution is not normal, then the Kendall's law is to be used. For analyzing the data. So please understand, if your variables do not have normal distribution, and if the scale of measurement is ordinal, you can use law. If the scale of measurement is interval or ratio, but the distribution is not normal, then also you can use law. I hope you have understood. Any question you want to ask? Now I am writing one title. Title is A Study of Kishore, the various types of distributions. Yesterday I told you, I suppose. Let me see whether I told you or not. I told you the types of distribution. One is a exponential distribution, another is regular distribution, another is U distribution, another is normal distribution, another is chi-square distribution, another is Poisson distribution. Like this, there are different types of distribution. And in parametric statistics, your data must have normal distribution. So these are the different types of the distribution. I hope you have noted down, Kishore. So let us take one example and then we proceed further. If suppose I have a title, let me write the title, A Study of, say, A Study of self-efficacy in relation to burnout of teachers of private colleges of Bhopal. Suppose this is the title and I am writing the objective. Suppose one objective is to study correlation between self-efficacy and burnout of teachers. And suppose my another objective is to study correlation between self-efficacy and burnout of male and female teachers separately. If these are my objectives, then my hypothesis will be number one, there is no significant correlation between self-efficacy and burnout of teachers. And the second is, there is no significant correlation between self-efficacy and burnout of male and female teachers separately. So this is how you can formulate your hypothesis. I hope you have understood. Now, let us go and take the data and I do the analysis. Now I am doing the analysis for the first one. The first one is to study the correlation between self-efficacy and burnout of teachers. So let me go to my data. This is my data. And here I have self-efficacy. Here I have burnout. So I go to analyze. Now where should I go? Let me go to correlation. And I go to the bivariate. Bivariate means two variables. And I click it. Now I have to find out the correlation between self-efficacy and burnout. So both these variables I can shift on the right-hand side dialog box. Here you can say Pearson, Kendall's, and Spearman. So I do not want Pearson, I want Kendall's. So I have highlighted the Kendall and I have deactivated the Pearson. So I have activated the Kendall's top B. Now you see the option. Do you want mean? If you want mean, then you can, because you are finding the correlation, the mean will not come. So now you can click. Now this is the correlation between the efficacy and the burnout. Now one more thing I want to tell you, that if you want to see the assumptions of the data, so let me go to that I go to analyze. I go to analyze and I go to the descriptive statistics. And then I go to the explore. This is for studying the normality, whether your data are normally distributed or not. So you can click it here and you can shift the self-efficacy and burnout on this side. On the right hand, then you go to the plot. And here is a normality plot. You highlight it. And then you say continue, and then you say continue. Now you can see for the self-efficacy, this statistics is significant because it is the error is 0.000. That means this value is significant at 0.01 level. That means your distribution is not normal. Because it is not normal, then you cannot use Pearson product movement correlation. So this is Colme-Guru, Simon. This is one test, another is Shapiro-Wilk. This is another, this is also says that the statistics is significant. That means the distribution is not normal. Now the burnout also is not normal. So both the self-efficacy and burnout, the distributions are not normal. And you can see the distribution also. Just see, this is the distribution QQ plot of the self-efficacy. If your all points are on the line, then it is normal, and it is not on the line. Some of them are below the line and some of them are above the line. I repeat, if your all points, they lie on the straight line, then the distribution of that variable is in normal. But here you can see the self-efficacy. In case of self-efficacy, some of the points are too much away from the line. Some of them are below and some of them are above. So it is not normally distributed. And another one also you can see, for the burnout also, it is not normally distributed because some of the points are above the line and some of the points are below the line. So that means the Pearson product movement correlation is a parametric statistics, and it requires the normal distribution of each variable. Now, in this case, the distribution is not normal. And if it is not normal, then you cannot use Pearson product movement correlation. Then you have to use Kendall's law. So now you can see I have done the Kendall's law. If you want, once again, I can do it. Go to correlate, then go to covariate, and the Kendall's has been highlighted. And you have shifted both the variable on the right-hand side dialog box. And then you say, okay. So this is your correlation value. This is the correlation value. Sandeep, if your data are normally distributed, but the homogeneity now this, in case of correlation, the homogeneity condition is not there. Sandeep, it will be if you are analyzing your data with the help of a t-test. Because in the t-test, the homogeneity of variance is important. But it is the correlation. In correlation, there is nothing like homogeneity. I hope you have understood, Sandeep. So therefore, you need not to bother about the homogeneity. You have to bother only about two things. Number one, distribution. Number two, the scale of measurement. Whether your data are on nominal scale, ordinal scale, interval scale, or ratio scale. These are important. Now, you know that the correlation between them is minus 0.846. So the value is minus 0.846. And you can see here that here the significance is 0.00. The meaning is that it is significant at 0.01 level. And you can see here is a double star. Whenever there are double star, that means the value is significant at 0.01 level. Now your N is 300. And degree of freedom will be 298. because there are two variables. So you have to subtract the 2 from 300. So 298 will be the degree of freedom. So let us see how do we make a table and how do we test our hypothesis and how do we write the interpretation. Now this is my objective. So I have the objective. Now, if this is the objective, what can be the table heading? Now, if you are writing a paper, then in the paper, it may be table number 1. But if you are writing a thesis or a dissertation, it will be in chapter number 4. So you have to say 4.2.0. Because 4.1.1 will be introduction of chapter number 4. So the 4 means it is the 4th chapter. 2 means it is the second main heading because I have written 0. So here it will be the correlation between self-efficacy and burnout of teachers. Now this will be the caption heading. And this caption should not go up to the width. You have to break it like this. And then you have to say the first objective was to study correlation between self-efficacy and burnout of teachers. Okay, I am repeating Sukraj Singh once again. So let me go to my SPSS. This is my SPSS. Now read, see carefully. I first go to analyze. And I click it here. Now I want to know whether my variables, they have normal distribution or not. Then I go to the descriptive statistics. And from descriptive statistics, I go to explore. Is it all right? Have you understood? Now I click it here. Now my dependent list makes those variables between which you want to find out the correlation. So it is a self-efficacy and burnout. Because I want to find out the correlation between these two. Now I go to the plot because I want to see whether my distribution is normal or not. So plot. Now here is normality plot with test. So I highlight it. Lakshmi, you are asking too much. I will not be able to share any of my document on your WhatsApp. I cannot do it and I am not very good at it. So do not ask me something which I cannot do. So now, after highlighting normality, now I say continue. And now I say okay. And now let me see where is my output. This is my output. So now in the output, you can see that these are the test of normality. You can see test of normality. One test is Kolmogorov syndrome. And here for the self-efficacy, the value is 1.22 and it is significant at 0.01. What is the meaning? The meaning is the distribution of self-efficacy is not normal. So the condition of normality is not met. The second also burnout is also not normal. So they are not normally distributed. This is another test. Saprio, Wilk. Here also the statistical value is 0.943 and it is significant at 0.01 level. That means the distribution of self-efficacy is not normal. Similarly, the distribution of burnout is not normal. So from the test of normality, you know that the distribution is not normal. Now, if you proceed further, then you can see this is QQ plot, quartile plot of the self-efficacy. If all your points are on the straight line, then it is normally distributed. But if the points are not on the straight line, then it is not normally distributed. So in case of the self-efficacy, some of the points are below the line, some of the points are above the line, and some of the points are below the line. That means all points are not on the straight line. That means the distribution of self-efficacy is not normal. Now, for the second variable, in the second variable also, the burnout, that some of the points are above the line and some of the points are below the line. So that means all points are not on the straight line. So that means the distribution of the burnout data is not normal. So since the distribution of both the variables is not normal, that is why the data were analyzed with the help of Kendall's law. Is it clear now? And what is the Jamovi? Is it a name of the statistical technique, Sandeep?
Sir, this is a software like SPSS. This is free of cost.
I don't know. I have never seen. I have never used, so I don't know. I have used the SPSS and I have also used your Excel. So therefore, I will not be able to tell you whether it is possible or it's not possible. I only can say about SPSS, it is possible, it is given in SPSS. Sukhraji, you cannot find out that which are the outliers. Outliers are always taken out. Okay, so therefore outliers mean either very small value or very large values. So you can see the data and then you can find out whether it is not or not, whether there are outliers or there are no outliers. So now we are at the interpretation. So the first objective was today to study correlation between self-efficacy and burnout. The data of self-efficacy and burnout of teachers are not normally distributed. Are not normally distributed. Thus, the data were analyzed with the help of Kendall's, law. And the results are given in table. This is the fourth table and the first table, fourth chapter, first table. So the number will be 4.1. So here table 4.1. Here is variable. And the variable here are two. One is self-efficacy and another is burnout. And here it is your Kendall's tau B coefficient. And this value is minus 0.846. And it is significant at 0.01 level. So if you want, you can write double star here and below you can write double star and you can say significant at 0.01 level. If you do not want to write the double star, then you can remove everything and then you can add one more column here and here you can write remark and you can say the probability is less than 0.01 and this p must be small because small p is the probability and capital P denotes something else. So here you can say the correlation coefficient between self-efficacy and burnout of teachers. or otherwise you can also say like this, that if you don't want to write the correlation, you can say Kendall's tau B coefficient between self-efficacy and burnout of teachers. Yeah, Kendall's T coefficient. And then you can now interpret from table 4.1. It can be seen that Kendall's tau B coefficient is minus 0.846, which is significant at 0.01 level with DF equal to 298. Now it indicates that there is a significant correlation between self-efficacy and burnout of teachers. Thus, the null hypothesis. Now, this null hypothesis, when you are writing a thesis, it is normally given in chapter number 1. And the interpretation is in chapter number 4. So for the reader, it is better if you can mention the hypothesis. So thus the null hypothesis that there is, and your hypothesis must be written in the present tense because there is a base. So it should never be written in the future tense. So the null hypothesis that there is no significant correlation between self-efficacy and burnout of teachers is, what should I write? Is rejected or is not rejected or is accepted? Yes, Sukhraj, you are right that if the error is 0.05, then it is significant at 0.05. If error is 5%, and if the error is 1%, it is not 5%. So this is okay. So here I cannot use the word accepted. I have to use it rejected. So null hypothesis is rejected. Now, once you write is rejected or is not rejected, your hypothesis has been tested. But interpretation is not over. Then you say the percentage of commonness between self-application burnout is. Now you see that your value is 0.846. So your value is 0.846. It is again multiplied by 0.846 and it is multiplied by 100. That means the commonness is 71.57. The percentage of commonness between this is 71.57, which is high. The percentage of commonness between self-application burnout is this, which is high and negative. So it may be said that self-efficacy and burnout of teachers were found to have significant negative relationship. So this becomes your finding. So this is the finding which you have got now. And now, if you want the analysis for the second objective, any question you want to ask? The percentage is percentage of commonness is equal to the correlation. You have to square it and then you have to multiply by 100. This is how you find the commonness, percentage of commonness. And here the value is minus 0.846. So minus is plus. So it's always plus. If you want to give reason, that will be in discussion, not in the result. So Rafi, have you understood? How do we find out? Okay, that's fine. And now, if you want the second objective, which we were having, this was the second objective. And this will be your 4.3.0. You can say correlation between, here you can write gender wise correlation between self-efficacy and burnout of teachers. Because I want for male and female separately, so I have written gender wise correlation between self-efficacy and this. Then I will say the second objective was to study the correlation between self-efficacy and burnout of male and female teachers separately. Now, let us see how do we analyze the data. So I go to my data. This is my data. So I go to my analyze and I go to the correlate, and then I go to the bivariate, and in the bivariate the Kendall's law is already there. So therefore, here that facility is not there that you do it for male and female separately. So what you can do is that now you go to data, because I want the data only of the male, and then I will find out the correlation between burnout and self-efficacy. And then I want the data of the female. So when I want data of the male, I want data of the female to be filtered out. So for that, I go to data. Please see it carefully. You go to select cases. You first click on data and then go to select cases and then click it here. Now here it is all cases, but I do not want all cases. I want if condition is satisfied, so I click it here. And then I click if condition is satisfied. Now we want gender. And we want gender is equal to 1. 1 means male teachers. And now I say continue. And I say okay. Now you can see that this is the gender, only the male data you will get, and the female data is filtered out. Have you understood this point or not? Is this point clear or not? And now you go to analyze and go to correlate and go to bivariate. And here Kendall's law is already highlighted. Then you say here, so you have the data. So this is your, so this is the correlation between self-efficacy and burnout in case of male, because you can see gender one means male. No, not, you need not to split file. You only have to select the cases. So this is the value which you have got, and this value is minus 0.826, and it is significant at 0.1, and this is in case of the male student, and there are 150 male, so it is DF is 148. Now I again go to data and I go to the select cases, and now I click on if. Now instead of 1, I will type 2. The moment I type 2, then it will take only the data of the females. So I say continue, I say okay, and now you can see that your data only of the females are there. 2, 2, 2. Where it is 2, it is 1 is written here. So now now I go to analyze, go to correlate, and go to bivariate. And it is Kendall's law, and I say okay, and this is my output. Can you see the output? So this is the value is minus 0.807, and it is significant at 0.01 level, and the DF is 148. Are you able to see this file or not? Okay, so now you have that result, and let me see how do we write the interpretation. Now you can see the same thing. My dear friend, Sapna, you see once again. You have not to see any command. That this is your data. So you have to go to data, and in the data you have to go to select cases. And let me first remove this. So you go to data and you go to select cases. So just click. Now here here this will be all cases. But because you want to filter the cases, so you have to click here if condition is satisfied. So no command is to be written. Then you say if. And now here, because you want to filter on the basis of gender, so you can shift gender here. So it is not a command. So you only have to shift the gender, and the gender is equal to 1, because 1 represents the male teachers. And then you say continue, and then you say okay. So now you can see this is the if you do not want separately, then I have already written the objective and written the result. But if you want to do separately, then and only then you need to do this. So it is analyze, you go to correlate. If condition is satisfied, 1, okay, this is okay, and this is fine. And now you go to correlate and this one, and these are there, all right, and then this. So this is the value, minus 0.826. If you do not use the word separately means you want to find out the correlation between self-efficacy and burnout for male separately and female separately. If you do not want to write the word separately, then your objective number 1. In objective number 1, I wrote to study the correlation between self-efficacy and burnout of teachers. Now there I did not bother about male teacher or female teachers. So if you want male and female, then you have to write the word separately. Separately, you understand that you have to take the data of the male and then find the correlation. Then you have to take the data of the female and find the correlation. That is the meaning. Sukhraj, I have already told you, we did not check the normality. I have already checked the normality because it is the same file, the same data file, and I already checked the normality of the burnout and the self-efficacy. If you want to do it for separately, that's perfectly correct. Nothing wrong in that. If you want to do it, you can do. You can go to descriptive and go to explore. And now here you want to find out the normality. So this is the normality. And because we have already taken the data for the male, I have filtered out. Let me just check once whether the data have been filtered out or not. Yes, it is filtered out. So let me remove this. Now I want to see whether it is normal distributed or not. So you go to analyze, then go to descriptive, and then go to explore. Now here it is your self-efficacy and burnout, and here is a label. If you want gender, so you shift the gender here. Okay, and then you can now see okay. Now you can have this is your self-efficacy and burnout. This is the test of normality. So you have these things. So let me see. Okay, let me once again do it for you. Let me see that I go to the data, I go to select cases and go to if condition, then gender is 1. I say continue, I say continue. Now, then I go to analyze, I go to descriptive, and I go to explore. And let me not do this. And here is a plot normal. So this is the data which you have got now. So you have this, the data. This is the data. And here it is only for the male. And you can see that it's not normally distributed. Now you again go to data and you go to select cases and click on, and you type 2 and you say okay, and you say okay. Now the data will be for the female, and this data was for male. You can see over here also gender 1. So this was gender 1, and now we are having gender 2. So let us see. We go explore, and then we do the now here it is the gender 2. Gender 2 means females. So this is the data of the female, and in the female case also is not normally distributed. So the data of both self-efficacy and burnout in case of male teachers as well as female teachers are not normally distributed. So therefore, you can use the Kendall's coefficient of tau. If all values are significant, that means data are not normally distributed. But if the values are not significant, then means the data are normally distributed. The significant means the data differ. It differs from the normal distribution. So Najim, yes, it is mandatory whenever you are analyzing the data with the help of a statistical technique, then whatever are the assumptions, it is better to test the assumptions. If you do not test the assumptions, then maybe your finding may not be all right. So it is very, very important that you have to see the normality if normality is the condition. If it is not, then you need not. So now you have understood that how it has to be done. Is it clear? Do I do the interpretation? So here once again, the data of self-efficacy and burnout of male and female teachers are not normally distributed. Thus, the correlation, thus the data were analyzed with the help of Kendall's coefficient. With the help of Kendall's tau B and the results are given for male and female separately. The results are given in table 4.2 for male and female separately. Now here I have table 4.2 and then I can insert the table . So here is a variable. This is gender. and here is a variable. So here is a male. Let us take that table on the next page. And here it is. Self-efficacy and then burnout. And here it is female. And here it is your Kendall's tau B coefficient. And here this was minus 0.826 and this is minus 0.807. Now, if you want, you can write, insert another one and you say remark. And remark is this P is less than 0.01. So this P should be small. And the same you can write here. And now you can see gender wise. Kendall's to be coefficient gender wise, Kendall's to be coefficient between self-efficacy and burnout of teachers. The way I have done the interpretation, the same you have to do it here. Let me copy and paste and make the changes. Nadine, but that has to be tested. Whether your data are are normally distributed or not. I said in the non-parametric statistics, your data will not have normal distribution, but then you have to test it. You cannot take it for granted. So I don't think that there is any point in getting confused. I have only told you how to test whether your data are normally distributed or not. Yesterday, I did not tell you how to test it, but today I am testing and showing you. So let us, I have copied and let me copy it here and make the changes. I have copied it twice. Now I say then from table 4.2, it can be seen that Kendall's tau B coefficient for male teachers is minus 0.286, which is significant at 0.01 level with DF 148, because your sample size was 150. So it indicates that there is a significant correlation between self-efficacy burned out of teachers, that the null hypothesis burned out of male teachers. Because I'm talking about the male teachers. So thus the null hypothesis that there is no significant correlation between self-efficacy and burn out of male teachers is rejected. Now the percentage of commonness between self-efficacy and burn out of male teachers is, now let us see how much it is. It is so it is 0.826 multiplied by 0.826 multiplied by 100. So it comes to 68.23. which is high and negative. It may be said that the self-efficacy and burn out of male teachers were found to have significant negative relationship. Now from table 4.2, it can be seen that Kendall's tau coefficient for female teachers is, and this was 8 minus 806. No, it is 7. This value is in the output, which is significant at this with DF is equal to 148. So it indicates that there is a significant correlation between self-efficacy and burn out of female teachers. Thus, the null hypothesis that there is no significant correlation between self-efficacy and burn out of female teachers is rejected. Now the percentage of commonness, let us find out. So here it is 0.807 multiplied by 0.807 multiplied by 100. So it is 65.12. 65.12. So the percentage of commonness between self-efficacy and burn out of female teachers is 65.12, which is high and negative. It may be said that a self-efficacy and burn out of female teachers were found to have significant negative relationship. So this is how you have to write the interpretation for male and female separately. No. Sukhraj, you can never find out the significance of difference between the correlation. There is no mechanism. You can find out the significance of difference between means, but you cannot find out the significance of difference between correlations. But you can find out whether the correlation value is significant or not. So therefore, the question you are asking is not valid. It is wrong question. So you cannot find out, you cannot compare, cannot check the significance or difference because I'm not finding the difference. And correlation difference cannot be found out. So difference is only of the mean. So you cannot do it. So this is how, like this, you can have another objective, that to find out the correlation between this and this variable for urban and rural area or for any other one, no problem at all. So this is how you can do it. Sukhraj, have you understood or not? That you cannot compare the two correlation and you cannot find out the significance of difference. The significance of difference can be only between means, because there are statistical technique which you can use. So, Kraj, you can find out the Pearson correlation coefficient also, whether the correlation is significant or not. You can find out, that's not a problem. So do you want that I should analyze the data with the help of Pearson? Sukhraj. Otherwise, if you want to analyze with the help of Pearson, you can do it. Nothing to worry about that. But Pearson only when your data of both the variables are normally distributed. But here it is not, so you cannot. I cannot send any document, Word document, I'm sorry. No Word file will be shared with any participant. I do not want to develop a bad habit amongst you. It is your duty to note down when I'm typing. I can type, then you should be able to also type or note down. So I have completed the Kendall's talk today. Next, whenever we meet next. So thank you very much. Keep learning. Stay safe.